In our last video, we talked about the general approach to solving the rectangle pasture problem for USACO December 2020 Silver. And the approach that we ended up coming up with is a very fast approach because it'll help us solve the problem within O of n squared time complexity. But today, we're going to be going over the code as well as how to specifically implement this problem. So as you can see right here, I already did the imports, created the class method and the scanner object. So let's get started. Right, well, let's see. We first need to be able to find the, we need to take the input, which is according to the USACO problem. The first line is going to be n, the number of cows, and then here I'm going to represent our input using a 2D array, which basically has the x and y value of all of the cows. So that's going to be n2, right? Okay. And then we're going to just do a for loop to take the inputs, and then this will be input I0 equals in dot next int, input I1 equals in dot next int. Okay, so after we've taken the input, what we want to do is, as we said here, we first want to convert this into the relative rank order of the coordinates instead of dealing with the x and y coordinates directly. The reason why we're doing this is because we want to deal with n instead of the coordinates, because if we're talking about n, then that's only maximum 2,500. But if we're dealing with the coordinates, that's going to be 10 to the 9th power, which simply doesn't allow any algorithms more than O of n time complexity. So let's translate this into a 2D. Let's translate this into a 2D array with the rank order. So what we want to do here is we want to first sort the array based on the x value, right? And this might not be the most efficient way to do it. There's many ways to do this problem, but this is just how I'm going to do it. So in order to sort a 2D array, we need to have a comparator, a custom comparator. So right, like that. And then we need to override the compare method. So public int compare final int entry1 final int entry2. Okay, so this is our compare method, and it's going to return integer dot compare. So we're sorting this based on the x value. So we're going to compare whichever x value has the greater value. So then that would return the value. In this case, the greater one would return 1 and the lesser one would return -1. So this is just sorting, so you don't need to worry about the details of this implementation. After we sort the 2D array based on the x values, we want to convert it into a rank order list instead of keeping the actual coordinates. So let's do for int I equals 0, I is less than, going through each x coordinate, and then input is basically our input array again, and then equals, we're just going to put I, which is the rank order. Okay, so and then what we're going to do next is we're going to copy this, basically do the same thing for y. Okay, and then copy this, but what we're going to change here is we're changing the y to the rank order, right? So now by the end of all of this, we would have sorted it based on the y value and converted everything into the relative rank orders. Now what we want to do is convert it back to the x value, because that's going to be the easiest way we can access this information, right? And up here, let me create a 2D prefix sum, because this will allow us to create our 2D prefix sum and then access information faster when we're trying to find the number of cows between a certain area. So this again will be a 2D array, but the dimensions will be n times n. Okay, so this will be pretty much sorting it. Okay, now we're gonna get to the interesting part, which is converting this or creating a 2D prefix sum. So remember here we defined the prefix sum as being the number of cows from the point 0, 0 to the point ij. So once we know that, it'll be relatively easy. Okay, so let's see. Okay, so if we're looking at converting this to a prefix sum, then we need to do a for loop for int I equals 0, I is less than n, I plus plus, and then we want to access all I and j's, j is less than n, j plus plus. Okay, so for so the way that we're going to do this is, let's look at this graph. So let's say the point 2, right? The point 2 is, the reason why it's a 2 here is because from 0, 0 to 2, obviously there can be 2 cows. But the reason in other words, how we can get this 2 is that it is both affected by what's in front of it and also what's below it, right? Because if there's a 1 in front of it, then this would increase by 1. If there's a 1 below it, it would also increase by 1. So how do we make sure that this is giving us the correct answer in terms of prefix sum? So the way that I came up with this is making a Boolean value, and let's call this, I don't know, tr for truth. Okay, so this is just a value. It's like a helper value used to support our loop. So what this is gonna do is pre-sum I j equals 1, right? If pre-sum ij equals 1, so let's see, did we create a pre-sum? Yes, so we have the pre-sum here, and then what this is going to do is, if there is since over here we okay, so something I forgot to do before we were able to get to that is to look at is that we need to create the prefix sum where all of the position in the cows were initially set to 1, and then all of the other positions are set to 0. So initially, so let me tell you what I mean here. So what I'm talking about here is that initially this point will be a 1, 1, 1, 1, 1, 1. The reason why we want to do this is it makes it easier for us to tell whether or not there's a cow at a certain point in the prefix sum. So that's why we want to do that. Okay, so here, since we want to do that, we need to add, let's see, where do we add this? Okay. When we're running through this, we want to add the prefix sum, the pre-sum is what we're calling it. Rather, let's add it here. Let's see. Right, pre-sum, and then we're doing input I0. What this does is it finds the I0. This is going to give us the x coordinate of this point on the 2D array pre-sum, and then the y coordinate is going to be I, right? So, well, rather it should be, right, yes. And the reason why we have it this way is because right now it's sorted based on the x values. So we want to sort this so that it's we want to, since we're sorting it based on the x value afterwards, here we're just gonna use since here it's originally sorted based on the y value, we're just gonna add it based on that. So let's test our code to see if there's any issues at this point. P2. Okay. Okay. Pre-sum input I0 I. Oh, okay. So this will be equal to 1. Sorry, I forgot to add the 1 there. So now let's see. There's some bugs in our program. For int j. Let's see. All right. Let's see. Entry. Okay, this should be entry 2. Entry 2, entry 2. Okay. All right, so now our program runs. All right, so back to what we were talking about. Here we want to go through every point on the prefix sum to fill it up. So if the prefix sum is a 1, meaning there's a cow at that point, then what we want to do is, so if there's a cow at that point, then what we want to do is, for the prefix sum, we want to set the Boolean value to true, and then if there's a cow at that point, then set the Boolean value to false, and then we set it to true. And you're going to understand why we're doing this later on. And then if j does not equal to 0, meaning that it's not at the bottom row, then we're going to do pre-sum ij plus equals, we're adding the pre-sum I j minus 1. So we're adding the pre-sum of the row below it. Because if we have a 2 here and then there's a 1, then this will obviously be 2 because it's including everything here but one more layer. Okay, so and then the next thing is we want to do if helper.contains let me just say j and then pre-sum I j plus plus. So let me explain what this code does. So okay, I forgot to create a helper here. So helper is basically a set, and it keeps track of all of the, how do I explain? So it keeps track of, let's say you're at the point 4, and then what the helper includes is going to be the x location 3, 0, and 2. The reason why we're doing this is because if we're looking at 4, then we know that there's not, let me think about how I can explain this so that it's easy to understand. Helper ij plus plus, helper I. So we're checking to see if there's something at the same we're checking to see if there's something at the same with the same y coordinates as the point we're at. Take this 3 for example, right? Once we add this 1 to the helper set, then we know that 3 is, when we go from here to here, we need to increase 3. So when we go from here, we do nothing. And once we see something, we add its x location to the set. So the next time we'll be able to know when we're looking at the same y value that there's a x value beneath it. So we want to add 1 to the number of cows within this area. So again, we need to create this helper set. And let's see, helper set integer helper equals new hash set. All right, so let me explain why we want to use a set instead of a list. So over here, we have a O of n squared time complexity algorithm, which is perfect. But if we're using a list instead of a set, in order to see if a list contains a value, it takes O of n time complexity, or not O of n, but O of the length of the list. So if that's what we're doing, then it takes another n, which makes our algorithm n cubed, pretty much making it impossible to pass the later test cases. So I made the mistake, and then I later on realized that what we need here is a set, because it takes constant time of one time to get to find whether an element exists in a set. So right, so that's the reason why we want to use a set. Okay, so once we add this to the list, and then we want to see if true, which means if there is a cow at the point that we're currently on, then we want to helper dot add j, right? So for instance, if we're on this point, we know that there's a cow here, so in the list we're going to add its x location, which is 3. Here we're going to add 0, 1, 4, 5, 2. So that's the point of this helper method. All right, so now that we created our prefix sum, all we need to do is just to find the answer, right? Okay, so to find the answer, again, we're trying to find between 2 points, how many points are within its x bounds, and above, I want to find the number of cows at the same height or above it, or at the same height or below it. And then those two numbers multiplied together will give you the answer. So let me just quickly do this, because I think this video is getting very long. So again, for loop, this will help us go through every pair of 2 points, and this should be I plus 1 because you don't want any repetitions. Okay, and then int y max. So the y max is the highest point between any 2 pairs of points. So math.max, and then this will be input I1. This will give us the y value of the first one, and then y value of the second one. Whichever one is bigger will be our answer. Y min, same thing, but this time we're finding the smaller one of the 2. Okay. All right, so, and then now we want to find the top area, or another way to say it is the number of cows above it, but it's easier to say top area, so that's what I'll call it. Top area, and then we'll just leave it like that, and then if I is equal to 0, which means if this I is over here, like the first point is has a x value of 0, then let's say let me draw this so it's easier to understand. So if you have a y value, let's say you're trying to find something, the number of cows between these 2 points, and has a y value of 0. So what you want to do here is, if this is 0, then pretty much this is not really a good example. Let's say between 1 and 4, right? So if this is 0, then what you want to do pretty much is to just, what's going to be the top area? Well, the top area is just going to be equal to, if you find from here to here, this rectangle, let me draw this like that, and then, well, I'm sorry, so it should be like this rectangle, and then you find the total number of cows in there, and then subtract this rectangle, and that'll give you the number of cows in this area, right? And then all we need to do is add 1 to include this cow, because we're looking at higher than or equal to this level. So what we're going to write for this is pre-sum j m minus 1 minus pre-sum j y max. Y max is the highest point from the top to the highest point plus 1. So if this is not at 1, then an example would be between, let's say we're trying to find between 2 and 5, right? Then it'll be more complicated. So we want to find the area from here to here, are the number of cows, and then we want to subtract that by let me just code it out while I talk. So top area equals pre-sum j m minus 1. Again, these will be the same, and I'll explain this. So essentially, if we want to find, so this is what we want to find. So we can find the area of this, and then subtract this part. So from this part to this part, right? That's what this is. That's what this is. Subtract from j to y max, and then we also want to subtract this part. So this part. So that'll be pre-sum I minus 1 m minus 1, and then finally we want to add from here. Since we subtracted this section twice, we want to add it back. So that's why we want to do plus pre-sum I minus 1 y max, going to the y max, and then again we're plussing 1 for the same reason as above. Okay, so again, in my other video, I think I already explained why the bottom area is going to be find the way it will be found. So in bottom area, I'll explain again here. So let's say we're trying to find the bottom area for this, let's say between points 2 and 4. So the bottom area is essentially within its x and y bounds. So it's this area right here, right? As you can see, it's this area. So all we need to do is find this area and subtract from this area. And whenever this area is equal, whenever it's the initial x value is at 0, this doesn't exist. So this, we won't really count it. So that's why our code for this is going to be if y max equals 0, bottom area equals 1. Okay, so the bottom area is this part. The reason why it's 1 is because we're still including this point. So, and then else, and then there's two cases. If I is equal to 0, if I is equal to 0, which means our starting point is at 0, then bottom area equals pre-sum j y min minus 1 plus 1 else bottom area equals, so here it's just this part plus 1, so just this part. If we're let's give an example here. We're trying to find this, and this is really straightforward because all we need to do is find this area and then plus this one. So that's what we're doing here. Okay, so and then otherwise we got to subtract the area on its left. So this should be a little bit more complicated, but not too much. So y min minus 1 minus pre-sum I minus 1 y min minus 1 plus 1. Okay. Oops. All right. So else, then here we go. At the end, we want to do again. So here we found the top area and the bottom area. So count plus equals top area times bottom area. And please see my first video regarding why I am doing top area multiplied by bottom area for the number of ways we can fence 2 cows. Okay, so and then finally all we have to do here is, did I declare the value for, did I declare count? Okay, let me declare count are, in this case they said that it has to be, let me go to the USACO question. USACO. All right. So in this case, they said it has to be, let's see, it has to be rectangular pasture. Yeah, in this case, it has to be, it's going to end up becoming a long. So it can be, fits, can be shown this quantity, which is our output, can fit within the signed 64-bit integer, which is perfect for a long and doesn't work for Java ints. So as you can see, long in C++. So our answer is going to be long ints, or rather count, as we're using here, equals 0. Keep adding it, and then at the end we're gonna do standard out, system.out.println count. And then here we still want to add n, right, to our answer, because this accounts for the fence that only includes 1 cow. And then the last one here, we want to add 1, which is the empty set. All right, let's test if our code works. Okay, 2 errors. Okay, prefix sum, and then cannot find symbol y max. 62, line 62 plus, do we do a y? Yeah, we have y max. Cannot find symbol. Pre-sum. What? This is strange. Y max. Why can it not find y max? Plus pre-sum I minus 1. This is pretty strange. Let me delete this and redo it. Oh, okay. Yeah, this is misleading. I thought it was referring to the y max. Okay, because the arrow is pointing here. But it's talking about the... Okay, there's no such thing as total area. It's just top area. Okay, let's run it and see Java solution. Okay, copy our input. Let's try this example. Exception. Index 1 out of bounds for length 4, line 69. Index 1. Okay. Let's see if y min. Okay, here it should be y min equals 0. Because y max is never going to be 0. Because, here we're looking at the bottom one. If this is going to be a 0, I mean, not a 0, but it's on the 0th column, which is the lowest column, then what we want to do is just not count this this number of cows. Okay, so that's a good problem that I'm glad we solved. 13. Let's see, what's the answer? 13. Great. Let's submit our code and see how well it runs. Okay, choose file. Here, let's see, what do we call this? It's in our demo folder. USACO practice. So USACO 2020 silver or P2 demo solution. All right, moment of truth. So far, so good. Fans starting to heat up. All right, great. So as you can see, we were able to solve all of the test cases using our approach, which has a time complexity of O of n squared. So that's it. And if you found the video helpful, then please leave a thumbs up, and I'll see you in the next one where we talk about P3 of the 2020 December Silver Contest. Thank you very much, and see you later.